I was gonna have to pour it, and bromine just loves vaporizing, which...
Dude, careful. It's time for some more NileRed. Specifically, making bromine in my parents' garage. Hey, everybody's got to start somewhere. That is quite the disclaimer. Those of you who don't know me, I'm Tyler Folse. I'm a nuclear engineer with a little over 10 years of experience in the commercial nuclear power industry. From engineering to operations to emergency response. I don't claim to know everything there is nuclear, but I can certainly share some knowledge. Let's see how he pulls this off.
I've been doing YouTube now for about 6.5 years, but in the last few years, it's grown at a pretty crazy rate. When I first started, I was just in my parents' garage, and I pretty much had nothing. I remember that it was a struggle to get even basic chemicals and glassware. Now, though, I have this office that I work in.
Laboratory.
And I also have
yes,
this entire lab that I built with my dad.
Like that he has a locker dedicated to radioactive material. That's important.
And when I think about it, it's almost unbelievable. I mean, I have things like real chemical storage cabinets, equipment like...
It's a nice setup.
Gas cylinders. I have a fume hood, or actually 2 fume hoods.
That's great.
Which are slightly better than what I used to have, which was just a fan and an open garage door.
Yeah, it's good to see how much he's invested in safety equipment.
I also have a drawer almost exclusively for hammers and another drawer just for blowtorches.
Appreciate the organization. I mean, it's kind of like you have organized equipment in a nuclear plant's control room. There are drawers specifically for responding to one particular type of plant transient, full of binders and procedures. And as far as doing stuff out in the field, the plant operators have emergency storage lockers, and each locker is designed for a specific event. Like there'd be one for fire protection, there'd be one for loss of power that has emergency temporary power, for instance. And hoses you would need to connect to portable battery-powered pumps. Organization matters, really in any industry, but especially when you're working with potentially hazardous chemicals or working with a nuclear reactor. It's important to keep all of your things well organized. And after the 3 Mile Island accident, all the procedures were changed that they're all symptom-based. So if you have a loss of coolant accident, for instance, you follow the loss of coolant accident procedure. It's cut in half down the page, where the left side is do this, and the right side is the response not obtained section. That means what you tried didn't work, so it tells you what to do next. And you can keep going down that right side if nothing's working, say, with your primary backup system. It's going to, for instance, then you keep going down and you go through your secondary backup system. It's important to be organized.
And when I think about all of this, I am super happy with how things are, and I'm really thankful for all the support and everything that I've gotten over the years.
He's done very well for himself.
But I can't help but kind of miss how bad it was. Like I said before, I used to do everything in my parents' garage, and it was far from ideal to say the least. I filmed all my projects on one table, and there was barely any space for anything else.
Man.
I almost didn't even have space for a camera stand, and everything was so crammed.
Looking at this makes me think of the early days of nuclear power. The first nuclear reactor, Chicago Pile 1, looks like this. This is what Minecraft looked like in 1942. It was built under a football stadium, which in nuclear terms might as well be your parents' garage, made of stacked graphite blocks and uranium lumps, and controlled by a guy literally holding a rope to the control rods. It's the garage lab state of nuclear physics back then.
I did my best to organize it and to be safe, but it was still undeniably some sort of hazard.
Oh, for sure.
However, I found that the added danger factor was kind of fun and exciting. The chemistry itself...
and that's probably where the comparison with nuclear is going to end.
...was challenging and dangerous enough, but I think I liked the bonus that my terrible setup added. It made everything that I did much more
Difficulty
difficult,
slider, yeah.
And I had to be way more precise and careful. This made many of my projects a lot more nerve-wracking and high stakes, but I think it also made them significantly more exciting. Now, though, it's much more official. I pay rent for my own space, and I have my brother and my friend working with me. I mean,
That's
it's
cool. I didn't realize it was his brother. The family business, the family lab.
way safer and still a lot of fun. And I'm able to do some higher end stuff that I never even dreamed of.
Superconductors.
However, I've been feeling that there's a part of me that misses that struggle and that danger. So, what I've been wanting to do for a while
The garage
is go
reflex.
back
Yeah.
and do some chemistry in my parents' garage. I've been really wanting to relive
Must have quite the accommodating parents.
how things were and to see if I
What
actually
if it makes them sign a waiver?
it. I didn't just want to do any random project though, and I specifically wanted to make bromine. Bromine's an element that's similar to chlorine, and it's a very angry, blood red liquid.
Bromine can be a fission product in nuclear reactions, one of the less common ones. But bromine 82 will decay to krypton 82 in 35 hours. So not exactly one of the isotopes of concern, at least as far as long-term nuclear waste goes. It's going to be the chemical reactivity. But it's not going to dominate your fission product concerns like iodine or cesium or strontium.
It's also one of my favorite elements, but that isn't the only reason that I wanted to make it. It's because it was one of my first garage projects that I felt was really pushing the boundary of safety. It has always stuck out in my mind as the first video that I really
From pool supplies, huh?
started to challenge myself and to push the limit of what I could do at home. I remember preparing for ages to make sure that I could handle everything and anything that could go wrong.
So as making it from pool supplies, bromine compounds can be used to disinfect pools. Could even be used in cooling towers at a nuclear plant. Though the first thing I think of it would be brominated flame retardant products. You see that occasionally in fire protection and You see that in fire protection systems and electronics.
I also remember some of my chemist friends telling me that I was going to die doing it. But anyway, now to get started, the first thing that I had to do was ask my dad for permission to use the garage.
That is a good first step to make sure the area that you're doing your experiment on, you have all the proper permissions. Just like it's perfectly fine to go into the Chernobyl exclusion zone. You just need permission. If you don't have permission, then that's a problem.
I have a question to ask you. Can we
Audio
use
only.
the garage sometime this week to make some bromine?
You need just like a verbal contract or something?
No waiver?
There's nothing in the garage is totally flexible all week.
To make bromine?
Yes.
Okay.
Okay. I mean, it's
That's it?
not a nuclear weapon.
Oh, man. So that's where the line is for his garage. Okay. Note that he said weapon, not reactor, so it could make a reactor. Could be like that one Boy Scout and just get all the americium and smoke detectors to make your own homemade neutron source.
With that out of the way, I started putting together a little chemistry kit that I could take home. To know exactly what I needed, I just rewatched my old bromine video, and I did my best not to forget anything. Based on what I saw, this seemed about right, and it was mostly just basic glassware and equipment. Some of it, like the funnels, the condenser, and the stands, were actually the exact same ones that I used in the original video. Now for the
Great, they hold
chemicals,
up over a
the
few
main
years.
ones that I needed were muriatic acid, sodium bromide solution,
Going back to the pool supplies again, muriatic acid.
and chlorine pool tablets.
Yep.
I originally bought all of these at my local hardware store, and I figured I could just get them there again. When I went to go buy them, though, they only had the acid and the pool tablets. They'd apparently stopped selling the sodium bromide years ago, which I think might be good, because we don't need more
Let's see. The intent is to protect the general population from residential exposure or chemical hazards. Okay.
people making bromine in their garage. However, this
They watched his previous video.
did make me a bit sad, and I started worrying that this project wouldn't be possible, or at least possible in the way that I wanted to do it. But luckily, after searching my lab for a while,
Get a bunch of
I
flame retardant.
actually found the sodium bromide that I had used in the original video. It was super old and only half full, but I figured that it would still be okay.
It's half full, not half empty.
Now, with all the chemicals and equipment, I took the 40-minute drive back to the garage.
He's in a
The
Cybertruck.
moment I walked in, though, I remembered exactly why I left. This sucks.
Going back to your roots.
Okay, that's a start. Oh, God. Okay. I don't know what to say.
You gonna move anything, or is that just gonna be part of the handicap he's using here?
I don't feel good about this. It was even more cluttered and worse than I remembered. But either way, the first thing that I had to do was clear the table. This ended up being a lot easier than I thought, and there wasn't actually very much to move. The hardest part was finding somewhere to put everything, and I ended up just shoving things wherever they would fit.
Keeping him in the garage? Okay.
With the table open, it was more or less good to go, but I wanted to see if I could find something to cover it. I spent a few minutes looking around the room, and I was very surprised to find my old glass tabletop. For most of my time in the garage, though,
Just
I
wedged in
actually
there.
used a
Love
different
it.
one that came from my grandma's old table. However, in 2017, that one exploded from an accidental lithium fire, and I replaced it
As one does. Typical NileRed hazard. Accidental lithium fire.
with this one. It was just a cheap tabletop from IKEA, but what was kind of funny was that for years, I thought that it had a zebra pattern. I also called it a zebra pattern at least a few times while setting it
It's kind
up,
of like a giant fingerprint.
and my friend couldn't help but say something.
It's also a fingerprint, not a zebra.
I thought it was a zebra thing. It definitely looks a lot more like a fingerprint now that I look at it. I think it was even called fingerprint tabletop. Either way. Good
To each
go.
their own.
Now with a completely clear and covered table, I was ready to start doing some chemistry. In my later garage videos, I filmed from the side that was closer to the bench, and I attached a backdrop to the garage door track thing. In the beginning though, when I made the bromine video, I wasn't nearly as advanced, and I filmed everything from the other side. I'm not exactly sure why I did it like that, because there was definitely less space on that side, and I think it was just because I liked the workbench background.
Everybody has a learning
But either
curve.
way, I decided that I
First reaction videos I ever made, I just used Zoom, because that's all I knew at the time. They're still up if you want to see some early proto-T-Pulse nuclear.
had to do it just like I did in the original video, and I started putting things together. Awesome. What was sad though was that after not even 5 minutes, I was already starting to get a bit frustrated. In my normal videos, I kind of obsess about having everything clean and proper, and that just wasn't happening here. The background's gonna be this garage. Everything's gonna be crooked. I'm gonna be doing stuff out of mop buckets. I don't know why I'm trying so hard to make it look nice. Oh well, no. The point of this is to relive what it was, and I should just...
There you go.
I should enjoy it. Here we go.
There you go.
Amazing. With both my stands in place, I attached a large flask to one of them. What I had to do next involved concentrated sulfuric acid, so it was time to put on my lab coat and goggles. Up until now, I think most of what I had felt was just annoyance, but after getting geared up, I started getting hit with that sense of danger.
Yeah.
It feels very inappropriate to be in a lab coat and goggles in this garage.
It's interesting, after the amount of extensive safety training he's probably knowledged himself up on since switching to the lab, I kind of had a similar feeling after working in the nuclear industry for a while. Was so used to things like lockout, tagout that it sometimes feels weird even just turning off power to something at your house that you're going to work on and not locking it out, even though you know you or your family are the only people there and know not to turn it back on until you're ready. But it's just kind of this weird feeling. It's like, I get what he says. I can't turn it off now that you're trained on how to do something with all the proper safety procedures.
It doesn't feel illegal. or too sketchy actually. It just feels dangerous.
Yeah.
I don't even have a running tap around here, so if I spill any of this acid on me, what do I do?
Mm-hmm.
I
I
can
wash
run
station.
to the tap down there, but it's just over 24 obstacles. What I had to do now was put together the rest of the setup, and I had to seal every joint with the sulfuric acid. This would prevent any bromine that I made from leaking out,
And that's because bromine dissolves greases. Yeah, in the nuclear world, ordinary gaskets and lubricants don't survive in a reactor, as I'm sure you can imagine. That's why ceramic seals had to be developed, graphite packing, and water chemistry that includes boric acid in the water. You have to design things for boric acid. There's an entire boric acid control program that has an engineering program manager in charge of that, among other things. But just like anything else, with extreme chemistry and extreme physics, you have to use different engineering tricks, some that might seem counterintuitive.
I couldn't use regular grease because the bromine would just instantly react with it. After I'd covered most of it, I wiped off the lower part with a paper towel, and I dropped it into the flask. I then added a 3-way adapter and an addition funnel, along with a thermometer and a condenser.
Okay.
To the other end of the condenser, I attached a smaller flask, and this was where I'd be collecting all the bromine. Now, with all this glassware in place, the main part of the setup was done. So far, it's not as bad as I thought it would be. Just safety-wise, it's awful still. But we also haven't started anything, so...
Yeah, you haven't started anything, but even just one big hazard is it's very cramped in there. Chemistry lab technicians at a nuclear plant, one of the first things you do before you start mixing or compounding, depending on what the task is to identify your escape path to the nearest shower and eye wash station. That would include keeping the walkways clear.
I guess we'll see. There still might be a disaster. Now, the next thing that I had to do was weigh out some of the pool tablets.
All right.
To do that, though, I needed a scale, and I had totally forgotten one. But thankfully, that wasn't a problem, because earlier, when I was just looking around the garage, I happened to find one. We have a high-quality scale right here.
Yeah, kitchen scale.
It's broken. It's just permanent. Oh, maybe it's not broken. It works. I don't know if I'll trust it. I mean, it's all we have. But anyway, with this hopefully accurate scale, I had to weigh out about 75 grams of the tablets, which were made of something called TCCA.
Yeah, in nuclear plants, there's many different ways to measure reactor power, whether it be neutron flux, megawatts of the reactor, megawatts on the turbine impulse pressure, a primary calorimetric calculation, basically heat balance calculation, or a secondary calorimetric calculation. In each of those, there's more than one channel to do things. And by that, I mean, take his scale, for instance. If this was a nuclear scale, there would be 4 different scales, and they would have to have a channel check requirement to make sure they all agree within the nearest, say, 10 grams, for instance. So one thing, I hope it works. That's a little different.
It turned out that each pellet was almost exactly 15 grams, and I ended up only needing 5 of them. This was very convenient when it came to weighing them out, but in this large puck form, it would be impossible to get them in the flask. So, I was going to have to turn them into a powder.
Okay, yeah. Wonder if this garage has its hammer drawer. Probably not.
When it looked good enough, I found some scissors that I last used when I was like 6, and I cut off part of the bag.
Safety scissors?
I then went back to the large flask, swapped out one of the stoppers for a funnel, and dropped in a stir bar. On top of this, I then dumped in all the powdered TCCA. After that, I added 30 mils of water to a beaker, along with another 30 mils of the muriatic acid. This was all added to the addition funnel, and I sealed it with another glass stopper and some sulfuric acid. The next thing to do was to add a hot plate, and unlike the original video, I also included a container. This container was very important in terms of safety,
Spillage.
just in case the flask broke or started leaking or something. It still wasn't the most ideal setup, but at least now if some sort of catastrophe happened, it would at least be somewhat contained. Now under the other flask,
hardly a reactor containment structure, but sure.
I added a bowl, and I filled it with ice. This would help keep the bromine cool, and it would reduce how much angry vapor it let off. There would still be some vapor that managed to escape out this part here, though, and I had to put together an inverted funnel trap.
Yeah, bromine is some nasty stuff. Volatile, corrosive, choking red fumes. Kind of going back to the early days of nuclear experiments. People knew theoretically that radiation, neutron fields specifically, caused embrittlement, even within stuff like stainless steel. A lot of times it was underestimated as people started figuring stuff out. But yeah, high energy radiation embrittles steel, will destroy seals, and ionize the air. Which is why now we use materials such as zircaloy cladding on the nuclear fuel itself, and steels with high nickel content that's more resistant to embrittlement.
To do this, I basically just connected a tube to a funnel and hovered that in a beaker. I then got another beaker, and I had to add something called sodium thiosulfate.
I have a little power supply, but I forgot that I can live without it.
Like he just comes in, no barricaded off area or locking the door so that you don't inadvertently walk in if you don't have the right PPE or something like that. There are borders like that separate, say, just radiation areas from contaminated areas, so you have to dress out in protective clothing so you don't spread contamination from the contaminated area to the not contaminated area. This is just funny to me.
Whatever.
You forgot this
I
operation.
forgot there was an operation.
Guess him walking in is just the equivalent of someone not realizing the maintenance schedule.
This thiosulfate is really good at neutralizing bromine, and I just had to dissolve a bunch of it in some water. It took a while because they were all big crystals,
Sure.
but they did eventually all disappear. After that, I poured it into the inverted funnel trap, and I brought it up until it was just above the funnel. With this setup, there shouldn't be any bromine vapors that are able to get out, and I'll talk more about how it all works later. Now, as another quick point of safety, I also mixed up a bunch of extra sodium thiosulfate solution. It was very important to do this, just in case I had any accidental spills or splashes.
Kinda the equivalent of a containment spray system in a nuclear power plant. So the purpose of this would be to catch and neutralize stray bromine fumes. Containment spray systems in an accident that really pressurizes up containment. It sprays out borated water to capture radioactive iodine and cesium so they don't leak into the environment. And like all other similar safety systems, such as emergency core cooling system, there are multiple redundant pumps for the containment spray system, just in case one of them breaks.
If any bromine ended up somewhere it shouldn't have been, I had to be able to destroy it as quickly as possible. Now at this point, I thought that I was good to go, but then I realized I completely forgot about the water for the condenser. To make this happen, I first had to fill a mop bucket
Outside
with
the
some
garage.
hose water. I then dropped in a small water recirculator, which is usually meant for a pond or a fountain. After that, I brought it back into the garage, connected the tubing to the condenser, and I plugged it in. I was expecting water to immediately start rushing through the condenser, but nothing happened, and it was apparently broken. I wasn't too surprised by this, though, because it was the same pump that I'd used in the original video, which meant that it was super old. I kind of thought that this might happen, so just in case I'd bought a new one, and I quickly swapped it out.
Nice, principles of redundancy. One of your pump breaks, use the backup pump.
This time, when I plugged it in, it worked, but the water was moving way too quickly, and I was a bit worried that the tubing might pop itself off.
I feel like there's way too much pressure in that for no reason. Hopefully one of the tubes just
After all this, the
Be like the day showing up for shift as a reactor operator or something says, hopefully I don't melt the core today.
setup was finally ready, and everything was more or less good to go.
So this is the moment to make the bromine. I feel a bit anxious. I'll admit it.
Good disclaimer. Specifically this method. Yeah, he'd be way better off back in his lab.
When I felt that I was ready, I started pouring in 400 mils of that sodium bromide pool solution. The moment that it touched the TCCA, it started turning yellow, and I think this was because bromine was forming. I'm not exactly sure what the reaction is, but I think somehow the chlorine in the TCCA was swapping with the bromine in the sodium bromide. If this were happening, it could be turning it into sodium chloride and releasing bromine.
I like how he shows the chemical equation here on the left. Yeah, given this environment that he's in, where you're not isolating stuff, the whole, I'm not sure exactly what's going on in here, that feeling is real.
I then turned on the stirring, and I let it sit there for a few minutes. When I felt that it all looked okay, I opened the funnel with the acid in it, and I let it slowly drip in. This caused it to start getting even darker, and this was because a lot more bromine was being made. Unlike the other reaction, this one was very well known, and the acid was reacting with the TCCA and releasing chlorine gas. This chlorine gas was then reacting with the sodium bromide to make sodium chloride and bromine.
There you go.
After all the acid was added, I let it
The
stir for a
distinctive
few
color.
minutes, and I took away the funnel. I also filled the bucket with a bunch of ice, and I cranked up the hot plate. Now, I basically just had to wait. I should mention, though, that this method of heating the flask with an open hot plate wasn't exactly ideal. I mean, it's okay and it does work, but it's much better to use something else, like a heating mantle. I just did it this way because, again, it was
Nostalgia.
how I did it before, when I didn't have any equipment.
This is going to be way before my time as a nuclear engineer. But I'd imagine there'd be some older reactor operators that reminisced about the days where control rods were hand cranked, shielding was lesser, you didn't have symptom-based emergency procedures, fission was done with really small hammers. Okay, maybe not that part. No reactor operator I've ever met, and I've met some ones that were pretty long in the tooth, has ever expressed a desire to go back.
As it warmed up, it didn't get that much darker, but it was slowly climbing out of the flask. I also started seeing it at the beginning of the condenser, and I eventually started collecting some blood red liquid. This
There we
was all
go.
bromine, and from this point on, it was usually pretty steady state. It was mostly just a matter of waiting for all the bromine to make it over. This would take at least a few hours, though, and I decided to use some of the time to ask my parents a few questions that I'd somehow never asked.
Good Lord, what's happening? It's excellent.
Go ahead and ask them close to the bromine experiment, too. Don't, step aside. All being said, though, you're going to want to have someone in the vicinity of this at all times, lest something happen. That is to say, something breaks, and now you got bromine everywhere.
applaud the effort.
Funny,
This is science. This is science, everyone.
What did you think was going to be the outcome of donating the desk?
I didn't have an outcome.
You thought it was just indefinitely going to
It's
be...
just a hobby. I couldn't tell. I mean, you were a chemistry student. I figured, if you were a musician, you'd be playing music, or a football player, you'd be exercising. So I figured it was just part of the ritual of
Good to see him being supportive.
being that. I knew that possibly being interrogated as having a meth lab might be on the, because when the door is open and the neighbors are looking in, what else can they conclude? Okay, that's excellent. Thank
That's
you.
it.
Carry on.
That's understandable.
What what did you think when I first started doing this in the garage?
It was interesting.
That's it? Were you ever scared? Were you ever, like, thinking that it was dangerous?
Maybe.
Did you ever have fears that there would be a disaster?
No, I had fears that we might be all getting poisoned.
I think that qualifies.
Slowly.
But, yeah, so you were never afraid when you saw something like that?
No.
Why?
Because I thought you had it under control.
No, it was all under control.
I trusted
It's good having confidence in your kids.
you.
But what happens if I just had too much confidence in myself?
Then we'd all die.
But anyway, now back.
Probably one of my favorite questions when I told someone I was going to be a nuclear engineer. So early on in my career, it was with my grandpa. And he thought it would involve a nuclear-powered train. And technically, we had 3 trains, basically 3 independent redundant safety systems at the plant. So, and at the time, just starting out, that sounded way cooler than the onboarding training stuff I was doing to begin with. So I just said we have 3 trains and left it at that. Nah, that's funny. I'm sure I'm not the only one who's used the word engineer and someone thought it had something to do with driving a train.
Back to the bromine. As I kept distilling it, the flask slowly cleared up, and it gradually looked less and less scary. I then looked over at the other flask, and I had a decent amount of bromine.
The scary
There was also
transferred
a
from
bunch
one
of water
flask
in there,
to
though,
another.
that had come over as
Flask, excuse me.
well, but it was just really hard to see. Also, up until now, I hadn't smelled any bromine, and when I looked at the trap, I could tell that it was working hard. It was now completely white
Working hard
because of
trap.
sulfur,
Oh, yeah.
which was being released as the bromine reacted with the thiosulfate. Eventually, after a total
It
of
worked.
about 7 hours, it was looking pretty good, and even the condenser was becoming colorless. At this point, there was probably still some bromine left, but it just wasn't worth waiting for it. So I decided to end it here, and I turned off the hot plate. I then left it there for a couple hours to cool down to room temperature. When I came back to it, the flask was colored again, which meant that there was definitely still some bromine in there.
Sure.
But either way, now that it was
Leftovers.
back to room temperature, it was safe to take apart, and I started by pulling out the thermometer. I then shot in some water to wash out any residual bromine that might have been in the adapter or the condenser. With this all clean, I was able to pop it apart, and then I moved on to the other side. I started by removing the trap, and then I got rid of everything else.
There you
Now,
have
taking
it.
a closer look at what I had, it was actually about half water. It was a little bit hard to see, but almost all of this water was floating as a layer above the bromine. This was happening because bromine and water don't mix very well, and bromine is also over 3 times denser. Up until now, the bromine had been clamped to this stand and had been either partially sealed by the distillation setup or completely sealed by a stopper. So, while making it was still definitely dangerous, it wasn't terrible. The real dangerous and scary part was what I had to do next to get rid of the water. I was gonna have to pour it, and bromine just loves vaporizing, which
Dude, careful. Yeah, this is the equivalent of early era reactor operators manually handling irradiated fuel rods with tongs or something, which technically worked, but we're not doing that today. Now nuclear fuel is handled remote manipulators, hot cells, during refueling outages at the plant I worked at, all underwater, though controlled for people on an elevated crane, kind of like this.
meant that I was gonna be making a lot of fumes. Also, handling it in general meant that there was a risk of dropping
Yeah.
it, which would be a catastrophic disaster.
Why did he not have his respirator on earlier when the thing was open? Okay.
That'd actually be a huge disaster.
You're making me nervous.
As a basic safety precaution, I was going to be doing everything over a plastic container so that any disaster could at least be somewhat contained. Just in case, I
Somewhat
also mixed
contained.
up even more sodium thiosulfate solution, which I figured I could throw on the bromine, before running out of the room. When I felt that I was ready,
Drop and run, throw and run. Reminds me of the mimetic drop and run Cobalt 60 rods.
I got out my respirator because I no longer had the luxury of a fume hood.
There you go.
I also opened the garage and I turned on the fan that I used to use, which I was honestly surprised was still there.
It's the equivalent of trying to cool down a nuclear reactor by opening the windows. It's why at chemical labs you see in a nuclear plant fume hoods, which he mentioned, also negative pressure systems and scrubbers to keep the contaminants in. The fuel handling building, where the spent fuel is located, also has a negative pressure system because you don't want the stuff to escape. In contrast to the control room, you have a positive pressure system in that you don't want the nasty stuff to get in. Oh, and everything has massive heat exchangers, redundant pumps, sealed containments, if you're talking about the nuclear reactor itself.
With the mask on and the fan going, I was pretty much good to go. The only thing that I was still missing was a face shield, but I didn't bring one. That wasn't a huge problem, though, and I just have to be even more careful.
I would say compared to the airborne hazard, no.
And not let any of it splash. When I transferred everything to a separatory funnel, I washed things down with some distilled water.
Okay.
The lower, almost black bromine layer was then drained directly into a smaller separatory funnel.
Okay. Looks contained. Nerve-wracking to watch. Okay.
Now, what I had to do next was the worst part. Even though there wasn't any visible water left, there was still a small amount dissolved in the bromine that I had to get rid of.
Oh, he's going for all of it. Okay.
I had to add some concentrated sulfuric acid, which wouldn't mix with the bromine, but it loves to pull and hold on to water.
Sure.
The danger here is that if there were a lot of water left, it could cause the sulfuric acid to heat up enough that it could boil the bromine. So I added it very carefully, and it turned out to be okay. However, the boiling risk wasn't quite over yet, because like with the water, it doesn't mix very well with the bromine. It was just floating on top of it, and I was gonna have to shake it. And in case it wasn't already obvious, shaking a mixture of
shaking bromine,
sulfuric acid and bromine isn't exactly the safest thing to do. Also, it was possible.
No, I can't think of an equivalent of shaking nuclear fuel or anything like that, because that's the next level in terms of preposterousness.
That there was still a decent amount of water left, which could cause things to heat up, build some pressure, pop out the stopper, and spill bromine everywhere. That exact accident actually happened to me once, but it was thankfully with something that wasn't dangerous. To prevent this, I had to make sure that I vented it often and quickly by opening the valve. Another added danger was something that didn't really have anything to do with chemistry. It's something that you can't really tell from the videos, but to make it look nice, I often have to awkwardly reach over and around the camera. In my entire time filming chemistry, I've never really had a major accident because of this, but it definitely increases the risk.
Yeah.
Thankfully, though, this wasn't the day for a disaster, and it all went okay.
I can imagine a senior reactor operator saying that after a post-plant evolution critique. Thankfully, today wasn't a disaster and everything went okay.
Now, as we saw before, bromine is very angry, and it likes to build up pressure. It's not so much that it would crack the container that it's in, but it's bad because it really likes to push itself out of everything.
Yeah.
When it escapes, it then reacts with everything around it, and it turns it all rusty and crusty. The only way to really tame it is to completely seal it in a glass ampule. To do this, I had to make one using a big test tube and a blowtorch. I heated it until it got nice and gooey, and then I pulled it to thin it out.
This is not unlike high-level nuclear waste vitrification. Once sealed, it's going to be inert, safe and easy to handle. You dissolve radioisotopes into borosilicate glass, seal them, and store them in canisters.
After waiting about 10 minutes for it to cool down, I started draining the bromine into it.
Look at that. You can tell he's a true professional by being able to do this with not an ideal set of tools and set of conditions.
This ventilator makes so much noise. So I held my breath.
To not ruin the sound.
With it now safely in the ampule, I blasted it again with the blowtorch, and as I pulled away the top part, the glass sealed itself.
Mm-hmm.
When I looked at it closer, it seemed like it was completely sealed, but I had to wait for it to cool down to room temperature before actually testing it.
Sure.
One of the biggest mistakes someone can make is making the ampule and then testing it right away. You have to wait till it's like completely cooled, otherwise flip it over, boils.
Yeah.
When I came back about 10 minutes later, I did the old flip it upside down and see if it leaks everywhere test.
The Dairy Queen test.
It was thankfully totally fine though. I then made a special padded chamber for it using a water bottle and some random foam that I found. Then, as an extra layer of protection, I then put this into another container.
There you go, triple containment.
Now at this point, the bromine was safe and secure, but I wasn't quite done yet. I still had a bunch of dirty glassware and waste all over the table. In general, I often don't show how I cleaned everything up, but it's a major part of chemistry, and it has to be taken seriously.
Yeah, I like the disclaimers he put there.
When I was working out of the garage, this was always the worst part, and it brought back some bad memories. I just really wasn't set up to deal with waste, and cleaning my glassware in general was a huge pain. Thankfully though, this stuff was pretty easy to deal with. For the most part, I just had to neutralize things with baking soda, and then blast it with sodium thiosulfate. This destroyed all the bromine, and it made the waste much more inert.
Another reason why you keep your hazardous waste separate so they don't react with each other.
However, the problem was that it was still waste, and even though it wasn't deadly anymore, I still couldn't just pour it down the drain. I'll instead be taking it all with me and storing it temporarily, and eventually giving it to a chemical waste company. But anyway, with that all dealt with, I cleaned up the garage, and I put it back to how it was. I then thanked my parents, and I very cautiously brought the bromine back to the lab.
There you go.
Thankfully, I was able to make it back without dying, and I guess that meant that I survived making bromine in my parents' garage.
Okay, 67%.
When I first came up with the idea for this video, I assumed that I'd...
Using the garage method. The fact that he was able to do it at all is something.
Know exactly how I felt about the whole experience the moment it was done. However, it took at least a few weeks to actually get my thoughts in order. I honestly still don't know exactly how I feel about it, but one thing that I do know for certain is that
hey, at least he's got his fume hood this time.
What I have now is better in almost every way, especially in terms of space and I've also realized that the excitement that I thought I felt back then had very little to do with danger, and I think that danger might have actually taken away from the enjoyment. When I think about it, I actually still feel that excitement with all my projects, and in fact...
That's good, and that's what people who have been in the nuclear industry for a long time think.
I think I'm a lot more excited about the stuff that I'm doing now. I think I was just suffering from the classic problem with nostalgia, where I was only selectively remembering the good parts. After experiencing how things were, I think it's pretty clear to me that I never want to go back. I'm now even more
says it as he just starts to pour it. That is wonderful.
Thankful for all the support I've received over the years.
This was a great one. Good to see some of NileRed going back to his roots. Thanks so much for the recommendation, and thanks so much for watching. I'll see you next time.